How do we disinfect water against Cryptosporidium? Have you ever wondered how we keep our water safe from pesky parasites like Cryptosporidium? This protozoan can cause serious waterborne illness and is tough to eliminate. Let's break down how we tackle this challenge. Cryptosporidium exists in a resilient form called oocysts. These oocysts can survive the chlorine levels typically used in water treatment. Because of this, we need to use more than just traditional chlorine methods to disinfect water effectively. First, we focus on physical removal. Filtration processes play a key role here. Techniques like coagulation, flocculation, and sedimentation help to clear out these oocysts. Conventional granular media filtration, which uses materials like sand or anthracite, is also common. However, sometimes these oocysts can slip through standard filters. To combat this, we turn to enhanced filtration methods. Membrane filtration technologies, such as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, are highly effective. These membranes act as barriers, preventing oocysts from passing through and ensuring cleaner water. Next, we look at chemical disinfection methods. Regular chlorine and chloramine are not very effective against Cryptosporidium. Instead, chlorine dioxide is a better option. It is a stronger oxidant and can inactivate Cryptosporidium more effectively with fewer harmful byproducts. Ozone is another powerful option that can also inactivate these oocysts, but it requires careful management to avoid unwanted byproducts. Ultraviolet light disinfection is another method we use. Ultraviolet light can damage the DNA of Cryptosporidium, stopping it from reproducing. The effectiveness of this method depends on the dose and exposure time. It works best in water that is clear, with low suspended solids. For smaller needs, portable ultraviolet units are available, while larger systems are used in municipal treatment plants. Thermal inactivation is also an option. Exposing Cryptosporidium oocysts to moist heat above 70 degrees Celsius for 20 minutes can effectively neutralize the parasite. However, this method is more suited for water heating or pasteurization rather than large-scale treatment. Another interesting method is solar disinfection. Natural ultraviolet radiation from sunlight can inactivate Cryptosporidium in clear water when exposed for at least 6 hours. This is particularly useful in emergency situations or areas with limited resources, but the water must be clarified first to remove particles that block ultraviolet light. In practice, municipal water treatment plants often combine these methods. They use physical removal through filtration and inactivation through ultraviolet light, ozone, or chlorine dioxide. These systems must meet regulatory standards that specify how much Cryptosporidium must be removed and inactivated. Regular monitoring and testing ensure that these systems remain as effective against Cryptosporidium. So, disinfecting water against Cryptosporidium involves a mix of advanced filtration and alternative disinfection technologies. Traditional chlorination simply does not cut it due to the parasite's resilience. By using a combination of these methods, we can keep our water safe and clean.